You guys, so in 1010, the biggest, like one of the biggest focuses is shifting from a parent function. So the parent function's f of x, we've seen this level of shifts in 1010. We just have to then up our game a little bit in 1050. There's just one extra shift they throw in there. But let's remember the stuff from 1010 because once again, it's the same exact stuff in 1050. Shifting always works the same for all functions. Now we do have to know our stuff for this. So everyone, wouldn't you agree the a value in front is a vertical shift, or a vertical stretch, a vertical compression? They use in this textbook the word scale. It doesn't matter. If I can tell you're saying it's a stretch, compression, scale, I get the picture here. We know that it only affects our y values. We've got to have this memorized. We've got to have this very straight in our heads. It only affects our y values, and to fix the y values, we just times them by a. Remember, it's just left and right. You verbalize opposite of what you see in this like equation, but then if you say right 7, you will add 7 to your x's. So shifts left and right, we do opposite of the sign, and that'll only affect our x values. Shifts up and down are added on the outside of the parentheses by itself, not grouped in with x. The shift up and down, the sign does not change. You verbalize what you see. That affects our y values. And then remember, this we need to memorize. A negative in the front versus inside grouped with x. So remember, a negative in front is a reflection over the x-axis, which only affects our y values. We times our y values by -1, which is nice because look, up here, if it's -a, you can hit 2 birds with 1 stone and times that times -a to the y values. You know what I mean? We know that because we've seen it in 1010. All right, and then remember the negative inside is a reflection over the y-axis. You're going to see that more often today just because I feel like in 1010 they kind of usually pick the easy one, and it's usually this one. Anyways, so a reflection over the y-axis, we times our x's by -1, which makes sense. Look, like right there, isn't x being times by -1, everyone? Yeah? Okay, so now there's just one difference. So now I'm going to the 1050 shifts. So still look, still a vertical stretch or compression, a vertical scale, still a shift up and down over here. See, still shift up and down. Now here is where it's new, okay? So we have never at the level of 1010 seen a scale, a multiplication number in front of x. Is that accurate? Like, right? I'm thinking back to 1010. Okay, so that is a new horizontal stretch or compression. So over here, you do have to now use the word vertical stretch or compression. We could kind of be lazy in 1010 and just say stretch or compression. You have to say vertical stretch or compression. Horizontal scales go to the x values, and it's kind of weird, but you don't just times by the number. I hope you're all really focusing right now. You do not just times by b. You actually times by the reciprocal of b. You have to flip it over a fraction and times by that. I'll try to explain why in just a second. Now here's the next thing you have to be careful of. We know shifts left and right are grouped in with x. So everybody look right here. You can't, if there's a b value in front, you can't just look at h. Here's the rule. To do a shift left and right, you have to have a leading coefficient of 1 right here. Do you guys see what I'm saying? So before you do shifts left and right, if there's a number in front, you have to say, okay, I can't do the shift left and right now. You're going to need to factor out this number, and then look at these two terms in like at that point to determine the shift left and right. Because if you factor out b, now your leading coefficient would be 1. So just something to keep in mind. Okay, so look, I'm zooming in here. Okay, so like make note of this, okay? So once again, see there's a 2x, the 2's inside. We would verbalize this as a horizontal compression. You can use the word scale. It's a horizontal compression by a half. You guys see how I reciprocated it? So you just times your x values by a half. Now I can try to explain, this is me trying to explain like why do we do that? So everybody, look, wouldn't you agree that x's are going twice as fast here? 2 times x would be twice as fast. Okay, our x's are going twice as fast. So now if I say graph that same graph, if it's going twice as fast, don't you only need half the amount of distance to still graph the same graph? So, right? Like if it's going twice as fast and I say, I don't want extra graph. I want the original graph only. then you only need half the distance because it's going twice as fast. And you would still have the same graph. Anyways, that's the best I can do to explain it to you. Okay, so look, now you would say, okay, I first have to take care of multiplication. I'm going to times my x's by a half. And then you would say, okay, a shift left and right can't be looked at as is. So this is what you would do. You would say, okay, I'm going to force this right here to be a 1. So I'm going to factor out the 2. See, look, I factored out the 2. And then I divide by 2, divide by 2. So do you guys see how I'm getting x minus a half now? So it's actually a shift of right 1/2. So the most common mistake is people will say right 1. So you have to have a leading coefficient of 1. So just some new things that we're seeing in 1050 come up. Okay, so let's just practice this now, okay? State the transformation and write an equation to all x, y points with the shift. So right here, let's verbalize to make sure we've got it down. So this would be, and you have to be specific because there's a horizontal and there's a vertical. So you're right. We'd say vertical stretch of 2. And then I write myself a note personally. I'm going to take my y's and times them by 2. This one's right 3. So won't we take our x's and add 3? And isn't this one up 1? So we need to take our y's and add 1. So now we're writing, it says, okay, and write the new general x, y points. So it's saying what happens to all the x, y points. Well, I've already made note of it right there. I just need to write it properly. So our x's are being added by 3 to go right 3. Our y's are going to be times by 2. We know multiplication comes first. And then after that, they're going to be shifted up 1. So that would be our answer. So really easy overall today, just because we've seen it in 1010 so much. Let's do a little more advanced of one. So people get tricked by this. Here's why. People will look at the 4 and be like, so that's multiplied. But look, they just have it out of order. They're doing this on purpose. They're trying to see that if you can see that this is equivalent to the following. So you would be like, oh, this is a plus sign. Well, let's reorder this in the order that we like to look at it as. So that'll just be 2f of x minus 3, and then plus 4 is actually back here. Do you guys see what I'm saying? So they're seeing if you're catching that adding 4 in front and back, and it is no different. Isn't it the same thing if you add 4 in front versus in back? We just are used to seeing it in back. So when I see that, go, oh, okay. Do not be a student who adds these together. You can't add those together. Multiplication goes first, so they're separate. So now from here, I think we're good. We would say vertical stretch by 2. So we'll take our y's and times by 2. Correct, everyone? Then you would say right 3. So we'll take our x's and add 3. Up 4. So we'll take our y's and add 4. So x plus 3, comma, y times 2. And then we're adding 4. Okay. All right, looking at this one. These are almost too easy, really. Okay, let's verbalize it. You would say reflect over the, it's memorization. X-axis. Way to memorize it. This is a vertical compress. You could use the word scale. Vertical compress of 1/3. I should have wrote a note of this. We're going to be timesing our y's by -1. We're also going to be timesing our y's by 1/3. I'm underlining what I want you to answer so that you can stick with me. That transformation, everyone. What is it? Left 2. So we're going to take our x's and minus 2. And then it looks like this one will be down 7. So we would take our y's and minus 7. So the general x, y's would be x minus 2 is the only x shift. Y's are timesing by -1 and 1/3. Let's just times it by -1/3 because that will take care of both pieces for us. And then after that, we'll minus 7 off of them. All right, let's actually do one with some oomph to it, a little oomph. Okay, so this one, finally we're at the 1050 level right here. So let's verbalize it for our notes. Because on the test, if they say verbalize it, we got to be able to say vertical stretch of 4. I'm going to make note to myself, we'll times our y's by 4. Let's go do the easy one. Isn't this one really easy? Down 5. We need to take our y's and minus 5. Then you'd say, oh, we have a scale factor, something multiplied to x. So you have to remember that is not a stretch of 2. It's actually reciprocated. So you would say it's a horizontal shrink, or you could say horizontal compression, or you could say horizontal scale. You know what I mean? It doesn't really matter what word you use. Horizontal shrink of 1/2. So we're going to be timesing our x's by 1/2. Do not be the sad soul that really knows their stuff and then says left 3. This is not accurate. You have to say, okay, for shifts left and right, I'm going to pause for a moment. I still have to keep parentheses. They don't disappear, but I'm going to factor out a 2 in the front of this and this term. So if I factor out 2, then I'm going to show my work. I'd be dividing by 2, dividing by 2. So what would be left? X plus 3/2. It's still in the parentheses. I've just factored it inside the parentheses. And we've already taken care of this. So I'm like, okay, that I just did this to now do my shift left and right. So verbally, what would this be? Left 3/2. You're right. So then we will be taking our x's and we'll be subtracting 3/2. So let's write our general x, y points. So let's focus on x. There were 2 transformations for x. One was multiplication, one was subtraction. We know multiplication comes first. Take your x's, times them by 1/2, and then we're going to then subtract 3/2. Right, everyone? That's why I like to write the notes as I go. It just makes this part go really easy. And then we know we take our y's and times them by 4. And then we are going down 5, so we subtract 5. Okay. So really, that's as hard as it gets today. You guys okay? All right, so let's just make sure we've got it. Okay, let's write out all the transformations really quick. We're almost finished with the lesson. Reflect over the x-axis. Y's are times by -1. Vertical shrink of 1/7. Our y's are just simply being times by 1/7. I'm going to do the shift up and down. Up 4. We know that we take our y's and add 4. The negative in the front of x is a reflect over just the y-axis, yes. The 3 is a horizontal, you tell me, compress by 1/3. When I say reflect over the x-axis, or when I said reflect over the y-axis, I should have also said, so I need to take my x's and times them by -1. Horizontal compress by 1/3 means we need to take our x's and times them by 1/3. And then before I do the shift left and right, I've got to go down here and say, oh, I need this leading term to be +1. So I'm going to factor out -3 just for a moment. So then if I divide by -3, divide by -3, won't it now be x plus 2? So now we would say it's actually left 2 units. So x minus 2. So now our general x, y's. X's, what are they being timesed by? Let's hit 2 birds with 1 stone, -1/3. Then after that, we went left 2, so we'll minus 2. Now the y's are just y times negative a seventh. And then after that, we're going to add 4. And really, truly right there is as hard as it can get because it had every single transformation. So if they said to you, so what happens to the point 1 comma 6? I will still write this. And then I go plug in 1 for x and 6 for y. You know what I mean? I just really think that's easiest. All right. Okay, cool. So this should now go really quickly here. It says, write the equation. Let's do it. It said, okay, let this be your parent function. So this time they did a square root one. Cool. So you would say, okay, stretch of 2, and it said vertical, so we know that goes on the outside. Square root, reflect over the y-axis. Doesn't the negative then go inside with x? So that'd be negative x. And then up 3, shifts up and down are added on the outside. So make sure you don't have it look like that plus 3 is under your radical, because that's different. That was our easy example. Let's do a medium level one. If x squared is the parent function, write the equation with these shifts. Up 2 units. So we're like, okay. Up 2 will be like added 2 out here, correct? Reflect over the x-axis. So where will that negative be? In the front. Horizontal shift of right 1. So in the equation, we need parentheses. X, right 1. So what do we put in the sign? Minus 1. Make sure you write squared. It's got to still have the same shape, the same format as the parent function. A lot of kids will forget to write the squared part. And then horizontal, horizontal stretching by a factor of 2. Horizontal stretching. So I'm going to go like this. Okay, wait a minute. Horizontal goes inside, true? And it said stretching by 2. So what would have to be in front to have it stretch by 2? 1/2. Now here's where people are going to mess it up. They're going to go like this. 1/2 x minus 1 squared plus 2. That's wrong. Here's why. If you're putting something in parentheses, you absolutely have to choose to distribute it through to this and this. See, watch. It'll work. So this time we should go like this. I could give you points for that. You guys see how it's in front? Or you could distribute it through. They always distribute it through. So we would say negative 1/2 x minus 1/2 squared. You guys see how I distributed it in? Plus 2. Now think with me, if you're going, oh, but that's not a shift of right 1. If you're saying that's not a shift of right 1, wait, let's make sure. Is it a shift of right 1? Because if not, then you're right, we messed up. Let's factor out a 1/2. If you divide by 1/2, divide by 1/2, isn't that x minus 1? So it actually is right 1. We're good. So you can see, like, we got to distribute it or we got to write it in parentheses. Otherwise, we wouldn't have the correct shift left and right. So that one is tricky. Is anyone confused? Are we all okay? Okay, let's do another one. Holy cow, this one has a lot. This time it's absolute value. Vertical compress of 1/2. So we'll go 1/2. I'm going to put absolute value signs and then x for now. Reflect over the x-axis. Isn't that in front? Horizontal stretch of 3. Horizontal stretch of 3. This is me just thinking. If we're stretching by 3, we got to times by 1/3 in front. Right 1. Oh, well then I got to use parentheses. Right 1. So it's just left and right, we do opposite. So won't it be minus 1? Like that. And then up 5. So our final answer would be negative 1/2. The straight lines are the absolute values. I'm going to distribute a third in. 1/3 x minus 1/3 plus 5. If you didn't distribute the 1/3 in, as long as you used parentheses, like the one above it, I could give it to you. Because I'm like, oh, they just didn't distribute it in. And it's fine if you don't. But okay. Okay, it says assume the parent function has this point, 2, 5. What will this transformation take that point to? So let's just write our general formula. So look at this. Since this is a vertical stretch of 3, we're going to take our y's times by 3. What are we going to times our x's by? 5. The reciprocal is what we times our x's by. And then we're going to take our y's and add 1. So it's x times 5, y times 3, and then after that we're going to add 1. So now I'm just going to plug in x, y. 2 times 5, comma, 5 times 3 plus 1. See, I plugged in x and I plugged in y. Everyone see? I'm plugging in x and y. So that'd be 10, comma, 15 plus 1 is 16. So that would have been your final answer. Same point. It's 2, 5. I'm going to write it just so I don't forget. Okay, once again, let's just write notes to ourselves. What are we timesing our x by? 1/3. Don't get tricked. We are not going right 1. What do we got to do? Factor out a 3, right, everyone? So let's just for a minute go factor out a 3. So then we would divide by 3, divide by 3. So it's actually x minus 1/3. So now it's right a third. Right 1/3. So don't we then add a third after we times by a third? Because it went right 1/3. So remember, shifts left and right have to be looked at with a leading coefficient of 1. You with me, everyone out there? And then down 2, we'll be taking our y's and minusing 2. So our general formula is x times a third. Then you're going to add a third to that. Our y's are just subtracting by 2. Plug in x, plug in y. 2 times a third plus a third, comma, 5 minus 2. So then it looks like we have 2/3 plus 1/3. Isn't that 3/3? Which is 1. So 1, comma, 5 minus 2 is 3. All right, this one tricks people. We're really so close to being finished, I promise. I know I've said that like 5 times, but this time I'm not lying. Okay, so this one will trick people. And it's simply just because it's not written how they're used to writing it. We're not used to having like this not split up. Like we're used to seeing it written split up. So let me explain. Let's just call this 3/5 minus 2/5 f of 2x minus 1. We're used to seeing it written like that. Do you guys see what I'm saying? And then we're not used to even seeing it in this order. When something's added in the front, we're used to seeing it added in the back. So we would have negative 2/5 f of 2x minus 1. And then this was positive 3/5, so then plus 3/5. See, now that I've rewritten it like this, I'm less likely to get tricked because now we know this goes to our y's, doesn't it? And then we know from there how to do this. This is our shift up and down. And we would continue with what we learned today with this one, calling it our horizontal shrink by a half, and then we would factor out the 2, and then it would be right a half. You know what I mean? So I'm just pointing out there are going to put things out of order sometimes. Don't let it freak you out. Just rewrite it how you're used to seeing it. Okay. All right, this will be the last. I don't think we're going to need a lot of these, but okay. So it says right here, graph this. It seems like they do one like this on the test. So it says, here's your parent function. Here's f of x. They say, graph this transformation right here. So what you're going to do is you're going to write down the original points in order. Let's do it. So let's go -2, 0, 0, 4, 2, 0, 4, -2. And now we're just going to perform the transformations. So I'm going to write myself a note. We need to times our y's by -2. True? Times by -2. Then aren't we going right 1? So we need to take our x's and add 1. And then up 3. So we're going to take our y's and add 3. So now I just go do that. I'm going to add 1, add 1, add 1, add 1. I'm going to just go like this and write down my new x's. Negative 1. 1, 2, 5. Then I'm timesing these by negative 2. And then after that, I'm adding 3. So 0 plus 3 is 3. Negative 8 plus 3 is negative 5. 0 plus 3 is 3. 4 plus 3 is 7. So we now go graph those points. You're going to know, it always kills me when someone on the test then has like a circle drawn. I'm like, it should look the same exact shape, just moved around. So you should have known something went wrong. You messed up somewhere. So negative 1 up 1, 2, 3. Over 1 down 1, 2, 3, 4, 5. Over 2 up 1, 2, 3. Over 5 up 7. Connect them in order. So wasn't it like a check mark kind of, just so I can like describe it to you? Yeah. And isn't this still like a check mark looking thing? So I'm like, I feel good. I don't feel like I messed it up. Okay. Do you guys think, okay, so I guess it's just the question is, are you guys ready to go? Do you guys want to do a few more like this? It says write the equation for this transformation. Do you guys need to see more like that? Creating the equation. Because we have done a few of those, right? Haven't we? Do you want more examples or no? You're good? Not good? Which one? You guys got to speak. I don't care either way. That's why I'm asking. Up here, she's good, but I want to hear other people. Okay, you're sure? Okay, sounds good. Then let's just make sure we understand the process to graphing something from scratch. See, look, they're going to ask you to graph an absolute value that's been shifted, a square root that's been shifted, a quadratic that's been shifted. And this is how they expect you to do it, okay? So they expect you to take off all the shifts. So you would say, oh, the parent function is absolute value of x. They want you to then make an XY chart for the parent function. So if I plug in negative 2, negative 1, 0, 1, 2, like 5 points is plenty. Absolute value of negative 2 calculates to be positive 2. Absolute value of negative 1 calculates to be positive 1. Absolute value of 0, 0. Absolute value of 1 calculates to be positive 1. Absolute value of 2 calculates to be positive 2. Then make note, memorized, I know this is going to create a V graph. And if it didn't, I messed it up somewhere. And now we just perform the transformation to the parent function points. Won't we times our y's by 2? You with me, everyone? Then we're going left 1. So won't we minus 1 to our x's? And then we're going down 3. So we'll then subtract 3. So our new x, y points that we're actually graphing are negative 3, negative 2, negative 1, 0, 1. Then it looks like 4 minus 3 is 1. 2 minus 3 is negative 1. 0 minus 3 is negative 3. 2 minus 3 is negative 1. 4 minus 3 is 1. If I go graph that, negative 3 up 1, just kind of guessing where it's at. Negative 2 down 1. Negative 1 down 3. Over 0 down 1. Over 1 up 1. And it's creating a V. A shifted V. I just did a, you know what I mean? You could do it on an actual XY chart. I mean like an actual graph. I have graphing paper over there you could use. So pretty easy, right? The reason I need to show you the next one is absolute values, for the parent function, you can plug in negatives, you can plug in positives. So that won't be true for the next one. The parent function for the next one, everyone, is square root of x. Now, you are going to want to be smart about this. You're going to want to make your life easier, not harder. So when you make your XY chart, be strategic in which points you pick to plug in. We can't plug in negatives. So let's start at 0. Square root of 0 is 0. That's a good one. I'll keep it. Square root of 1. Isn't that also a good point? Like a whole number answer. Square root of 1 is 1. Square root of 2 is a decimal. So personally, I don't want that one. But that's just me. Square root of 3 is a decimal. Square root of 4 is a good one. What's square root of 4? 2. Square root of 5 is a decimal. I don't want it. Square root of 6, square root of 7, square root of 8, square root of 9 is 3. I'm like, that's enough. And now we'll perform the transformation. So let's do it real quick. What will we be timesing our x's by? 1/3. That was our new transformation we learned today. You times by the reciprocal for horizontal shrink and stretches, right? And then we have to do, for shifts left and right, we have to go, oh, that has to be a 1. So we're factoring out 3 just for a moment. So then divide by 3. Won't that actually be x plus 2? So it's actually left 2. So after we times by 1/3, we then got a minus 2. That's a little squishy. And then down 4, we'll subtract 4 from our y's. So I'm going to have some decimals. That's fine. No problem. I mean, I have a calculator. 0 times 1/3, so I'm doing this right here. 0 times 1/3 is 0, minus 2 is negative 2. 1 times 1/3, I don't personally even want fractions for graphing. So 1/3, I'm going to do it on my calculator, minus 2 is negative 1.6. 4/3 minus 2 is negative 0.6. Isn't that 3 minus 2 is 1? Unless I'm crazy. Isn't 9 times 1/3 3? 3 minus 2 is 1. Okay. So then 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. 3 minus 4 is negative 1. Now this is where your knowledge, your background knowledge is going to help you. A square root graph, parent function, starts at 0 and it's a sideways parabola like this. So if you're graphing this and your graph doesn't look like that shape, then you messed up. So negative 2 down a 4. I'm just like guessing here. Negative 2 down 4. Like the negative 1.6 down 3. Negative 0.6 down 2. Not drawn to scale at all. Over 1 down 1. Is it still looking like a sideways parabola? Looks good. So I'm like, okay. Good, good, good. All right. Okay, this is our last example. I think we should probably at least write down the points or whatever. So it's not in the correct order. So you're going to reorder it. Write it as negative 2, 1/4 x squared, and then plus 3. So you're going to start with the parent function of x squared, make an xy chart. We know it will create a U shape or we've messed up. We can plug in negative 2, negative 1, 0, 1, and 2. For squareds, we can plug in negatives. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And now we've just got to go write what we're going to do. So don't we need to times our y's by negative 2? Okay, I'm just showing my work here. What do we need to times our x's by? 4. Up 3, we know we're then going to add 3 to our y's. So our quadratic has these new xy points. Looks like it'll be negative 8, negative 4, 0, 4, 8. Negative 8 plus 3 is negative 5. Negative 2 plus 3 is 1. 0 plus 3 is 3. Negative 2 plus 3 is 1. Negative 8 plus 3 is negative 5. Then I would graph those points and notice, and it will create a U shape. You know what I mean? It's just, you get the picture here? Definitely use some graphing paper so you don't have to like free sketch it because it's just honestly kind of annoying to have to do that. But that's the end of the lesson. So hopefully that just goes really smoothly for you on the homework 1.3. I'm here to help. Really by, hopefully next time I'll be able to have a it'll maybe be like 2 times, but I'll have a packet printed with the exercises so that you can use that instead of your Chromebook. But today, still no.